we're going to look at where the double angle identities come from. It might be tempting to look at this and say sine 2x, well, can't I just factor out the 2 and say this is 2 times sine x? But the problem with that is sine is not multiplication, it's a totally different function, so we can't talk about factoring something out of the sign, because to factor, it's multiplication. Signs are not multiplication, they're different. But what we'll do instead is recognize that 2x is x plus x. So that still says sine 2x. Looks a little different, but it says the same thing as the line above. And there's an identity for that we already know. The sign of a sum goes sine of the first, cosine of the second, plus cosine of the first, sine of the second. But multiplication's commutative. Sine x times cosine x times sine x. Those are multiplication, right? There's multiplication in between there. Those are the same. So it's 2 of the same term. 2 sine x, cosine x. So that's where the sign of a sum identity comes from. For the cosine, we're going to do the same thing. Cosine of 2x, we're going to rewrite as cosine of x plus x. And there's an identity for that, too. This is cosine x, cosine x. I'm doing the cosine of a sum, so I'm going to put the opposite in between. Sine x, and I can rewrite that more efficiently as cosine squared x minus sine squared x. And that's version 1. But then we have the Pythagorean identity that says cosine squared x is 1 minus sine squared x. So if we use that, so we're continuing here. Now I have 2 minus sine squared x terms. Might as well combine those, combine like terms. So I got 1 minus 2 sine squared x, and that's version 2. Or, from up here, instead of substituting 1 minus sine squared x for cosine squared x, I could do the other one. I can substitute 1 minus cosine squared x for sine squared x. Carefully. Parentheses are your friend. And this way I have cosine squared x, and then minus minus, that's another cosine squared x positive. My 1 is negative, so this is 2 cosine squared x minus 1. And that's version 3. All 3 of those are identical to cosine of 2x, and which one you pick at any given moment just depends on your goal, what you're aiming for. For the tangent, we'll do the same thing. 2x is still x plus x. So I'm going to have tangent of a double angle, tangent of the first, plus tangent of the second, over 1 minus tangent of the first times tangent of the second. And we can clean up both the numerator and the denominator. On the top, I have 2 of the same thing, so that's 2 tangent x. On the bottom, tangent x times tangent x is tangent squared x. We can write it more efficiently like that. And there's our identity for tangent of a sum.